So last time we discussed, so if we have the function f of x, we can find its derivative using the limit, right? The limit of delta x goes to the 0, delta f over delta x, right? So what does it mean graphically? So let us try to draw this function. So let's say this is the function f of x. This means something, okay? So for example, this might mean the distance which is covered, this might mean the velocity at some point, or this might mean your cost, or this might mean your revenue in some period of time, okay? So you choose the 2 points, x1 and x2. So the distance between these 2 points is the delta x, okay? So delta x by the definition is x2 minus x1, right? So the difference of the height of these functions is the delta f, okay? So this is delta f. So we are interested to know how the function has changed with respect to the x, okay? If this is the distance, for example, let's say at the x1, which is equal to the 1 hour, the distance was 60 kilometers, and when the xt is equal to the 2 hours, the distance is 120 kilometers. So we are not interested to know how the distance has changed. So you see, so the distance has changed 60 kilometers. We are interested to know how the distance has changed with respect to the time. Okay, so the distance is changing in average with respect to the time is 60 kilometers per hour. Okay, so this gives you the average velocity. So graphically it looks like the slope of this line. Okay, so where you take the limit of this one, where this delta t, or delta x, sorry, goes to the 0, it gives you the instant velocity, instant rate of change of the distance with respect to the time. Okay? For example, let us talk about that example. Let's say the function f gives you the grades on calculus. Okay? So your grade might be good, your grade might be better or worse. So you will just put the some arguments here to this function and it gives you the grade. Okay, so if you put the function of midterm, it gives you the grade of the midterm. If you put the final, it gives you the grade of the final. Okay, we're interested to know how your grade has changed with respect to the something. Okay, so not just like your grade has changed from 60% on a midterm to the 80% to the final. This is what we want. So the grade might depend on the performance of your homeworks, right? Or your understanding in the lectures, and so on. Okay, so we're interested to know how your grade is changed if we increased the homework performance. Okay, so if your homework performance is getting better for 20%, how much your grade is changing? This is what we would like to know. So we would like to know how this function is changing with respect to the something. Okay, not just like a pure change. Okay, but sometimes this function f might depend on the t and other functions, right? So we say the f of x depends on the g of h of x. Okay, so for example, last time we discussed this issue. So we said, so have your results, let's say, okay, let's say g gives you the grade on the calculus 2, h is the grade on calculus 1, okay, and x is your performance or your understanding of the chain rule in calculus 1. Okay? So now, when you take the derivative of the f with respect to the x, the meaning of this is have your grade on calculus 2 has changed when your grade on a quiz on chain rule is changed. You know what I mean here? So X means like the quiz results on your midterm, on the chain rule. Okay? If you change the result of the quiz on the chain rule, have your grade of the calculus 2 is changing. Okay? So this is like, in order to know this, we need to know the chain rule. Okay? So last time we learned about this, we say that if I would like to find the derivative of the f with respect to the g of x, with respect to the x, so we have to first of all figure out the derivative of the f of g of x with respect to the g of x first, right? Then multiply this to the derivative of the g of x with respect to the x. Okay? In terms of our example, it means find how your grade on the calculus 2 is changing if you change the grade on calculus 1, and multiply this to the rate of change of your calculus 1 result when you change the quiz results. Okay? For example, if your quiz result on a chain rule becomes 20% better, then how much your calculus 1 grade is changing? For example, for 10%, you will find this. And now, if you change, because of this quiz, the result, the grade of the calculus 1, how much your calculus 2 grade is changing? Okay? You understand what we want? So what does it mean? Like, we would like to reveal, we would like to understand what does it mean, this derivative. Okay? Derivative is not just the change of something. It is the change of something with respect to the another thing. If you change the time, how the distance is changing. Okay? This gives you the velocity. If you change the time, how the velocity is changing. This gives you the acceleration. Okay? So this is the rate of change, or derivative is the instant rate of change of some function with respect to another thing. Okay? Good. So when we do the exercises on a chain rule, it is really important for us to understand what is the structure of this function. Okay? So in order to do this, we've learned about the composition of the functions. So if you go to the quiz, there are two types of the problems there. So the first problem is, if the age of x is equal to the sine of x, and g of x is equal to the x squared, you're asked to find what is the composition of the age and g, which is age of g of x. So basically you have to substitute this x inside the sine with the g of x. Okay, so you have to write sine of g of x. What is the g of x? Is x squared. Okay? So this is a problem where you're given the two functions, and you're asked to find the composition of these two functions. Okay? But in order to solve the derivative problems using the chain rule, you need to be able to do this problem in the reverse order. Okay? If you're given a function f of x, which is sine of x squared, what is the decomposition of this function? Okay.
Sine and x squared.
Okay. So what is the decomposition of this function? Okay. So give me the two functions h of x and g of x, so that their composition gives me f of x. Okay. So this is our problem. You're given a function. We would like to know what is the decomposition, not the composite. Okay. We would like to decompose this function. If we are able to do this, then we can find the derivative of the function. Okay. So decomposition of this function is you told, so this will be sine of x and the x squared, And we've learned last time that the derivative of the f with respect to the x, it will be derivative of the f with respect to the g of x, first of all, multiplied to the derivative of the g with respect to the x, right? In order to do this, first of all, you should find, sorry, not f, g, h, sorry. So you should find the derivative of the h. So what is the derivative of the h? Cosine of x. And what is the derivative of the g? It's tx. So here I need to substitute not just the h prime of x, I need to substitute h prime of g of x, right? So basically I need to substitute here cosine of g of x, right? Which is multiplied to the tx. So if you substitute the g of x to there to the cosine, you will get the cosine of x squared multiplied to the tx. Okay? So the most important part of solving such a problems is decompose this function. Okay? Not decompose them, but decompose them. This is the most important part. And it is also really important to us to understand what is the meaning of the derivatives. Okay? So could you please tell me from this perspective, from the understanding that the derivative gives here the rate of the change of the function with respect to some variables, tell me why the derivative of the constant, for example 2, is equal to the 0. So y f prime of x is equal to the 0. Not from the mathematical perspective, but from the perspective of the rate of change. Yes?
Maybe by the definition of derivatives.
Not by the definition of the derivatives. Explain me why the derivative is equal to the 0. Yes?
First is horizontal line and no slope, no change in something. It doesn't change. It's constant, no change.
Okay, so again, yes, I mean this is just the horizontal line, right? This is f of x at height 2. Okay, so what gives us the derivative? So I need to choose the 2 points, x1 and x2, right? Where the distance between them, delta x. And I need to find the ratio of the changing of this function to the delta x, right? So if you change x1 from x1 to x2, the x from x1 to x2, how your function is changing? It is not changing, right? So when you change the x1 and x2, your function is not changing. So that is why derivative is equal to the 0 from this perspective. Mathematically, it is clear, right? So basically, you measure the change of the height of the function. What is the delta f? How the height is changed? 0, right? It didn't change. Do you remember what was the delta f? Graphically, it means so you choose the 2 points, and delta f tells you how the height is changed, okay? It is plus if it goes up. It is minus, it went down. Okay? For example, if your function looks like this, and if you choose the 2 points, x1 and x2, the change of the height, delta f, will be some negative value. Right? Because you always, so delta f by the definition, it is f of x2, which gives you this point, minus f, or this point, sorry, this point, f of x1, which gives you this point. Okay? So if you subtract them, you will get some value which is negative. Okay? So if you have the function which is constant, and if I'm asking you how this function, the value, is changed when you change the x, it didn't change it. Okay? The instant rate of change is equal to the 0. This is similar to the example which we considered was another group. I told them, let's assume f of x, the grade on a course of history, okay? And x is still your understanding the chain rule, okay? F is your grade on a course of history, which you're going to have next year. X is your performance on the quiz of the chain rule, okay? So this will be equal to some function, okay? Now I would like to understand, have the grade of your course on history is changed if you will change the grade on a quiz on the chain rule. If you will understand the chain rule better, how the grade on the history will change. It doesn't change this, right? So this will be equal to the 0, okay? So maybe your function is changing, okay? But it is not dependent on the chain rule, okay? So that is why. Do you understand this? So for example, your grade from the midterm until the final on a history is changed, it is increased, but it doesn't depend on your understanding the chain rule, okay? So if you are asked to find the delta f, you will just subtract your grade on the final and your grade on the midterm on the history, okay? But if you're asked to find me what is the rate of change of your grade on the history with respect to your grade on the quiz for the chain rule, then this will be equal to the 0 because they are not dependent, okay? So let's say, not x here, but y, okay? So that is why. If your function f of f is equal to the sine of y, and if I ask you, find the derivative of this function, this is equal to the 0 if you know that the y do not depend on x, okay? Do you feel this, right? So, do you feel what is the meaning of the derivative? It is how your function is changing with respect to something. Okay? Good. So, let's do a couple of more examples on a chain rule. Oops. Let's say I would like to find the derivative of this function cosine of tx plus 1 with respect to the x. Okay? So the first task is you need to figure out the decomposition of these functions. Okay? So write down the f of x as the composition of the t and other functions h and g, so that their composition gives you the f. Okay? Could you please tell me how I can write the h? So h is always the outer function. Okay? So h was equal to the cosine of x, and g of x is equal to the tx plus 1. So how I can check whether I'm doing everything correctly? So I just need to substitute the g of x inside the h of x, right? So I need to substitute this x with the g of x. So let us substitute this cosine of tx plus 1. Correct, this is f of x, right? Our decomposition is correct. On the next step, what we need to do is, we need to find the derivative of the h, which will be minus sine, right? Derivative of the g, which will be 2, right? Then we need to substitute everything to the formula. The derivative of the f with respect to the x is the derivative of the h, the outer function, but not with respect to the x, but with respect to the g of x, right? Multiply to the derivative of the g of x with respect to the x. So instead of putting here x, I need to substitute the g here, okay? So this will be minus sine of tx plus 1 multiplied to the 2. Okay? This is like a general strategy how to solve such a problems. So let's do one more example. So if you have any questions, so you need to ask. So let's say f of x now is equal to the sine of square root of 1 minus x. So what is the derivative of the f of x? Again, okay, so there are two ways to solving this, okay? It depends on what is easier for you, okay? So either you will substitute this 1 minus x with some function, as we did this, either you will just substitute it with some variable, for example, u, okay? You will say u is equal to square root of 1 minus x, okay? Then your function f of x becomes sine of u, okay? Then the derivative of this function is equal to the cosine of u multiplied to the u prime, okay? This is the first way. But I would suggest you to do this with the decomposition because it really helps you to understand like a really inner thing, which is what is going on there. So first step. So could you please tell me what is h of x and what is g of x so that their decomposition gives me this function? h of x is equal to the sine of x, g of x is equal to the square root of 1 minus x. Right? Because now if you substitute the g of x inside the h of x, it gives you the original function. Right? If you substitute this to here, it gives you sine of square root of 1 minus x. Right? So on the next step, we need to find the derivative of the h. Derivative of the h is equal to the cosine of x. Derivative of the g, what is the derivative? So here again we have to use the chain rule. Okay? So what is the derivative of the square root of x? It is 1 over 2 square root of x. Right? But now I have to multiply this to the derivative of the inner function. Right? What is the derivative of the 1 minus x? What is the derivative of the 1 minus x? Minus 1. Right? Minus 1. Now we need to write this down. So f prime of x is equal to the h prime of g of x multiplied to the g prime of x. So this will be equal to the cosine of, not x, right? I have to write square root of 1 minus x multiplied to the minus 1 over 2 square root of 1 minus x.